AVL tree deletion. Today we are going to learn, and suppose this is a tree. First it is given, so first we will cross check the balancing factor. As 29 there is no child, so balancing factor is 0. 23 there is no child, so balancing factor is 0. 28 one child on left hand side, one child on right hand side, so balancing factor is 0. 18 there is no child, so balancing factor is 0. 22 there is one level on left hand side and two level on right hand side, so we can say +1 -2, so -1. 52 there is no child, so balancing factor is 0. 48 one child on right hand side, so balancing factor is -1. 44 three levels on left hand side, two levels on right hand side, so +3 -2 +1. So this tree is balanced. That is, till now there is no problem. Now suppose if we are deleting 52, what we are deleting? We are deleting 52, this node. So now how the tree will be? Tree will be like this. Tree will be 44, 22, 48, 18, 28, 23 and 29. So again we will cross check for a balancing factor. 23 there is no child, so 0. 29 there is no child, so balancing factor is 0. 28 one left on one right, so +1 -1 0. 18 there is no child, so balancing factor is 0. 22 one on left hand side, two levels on right hand side, so +1 -2 -1. 48 there is no child, so balancing factor is 0. 44 three levels on left hand side, one level on right hand side, so +3 -1 +2. So we are able to see now balancing factor is +2, because in AVL tree what balancing factor can be possible? 0, +1 and -1. But if it is beyond this, as we are able to see +2, then we have to do rotation. And as in the deletion we know the root node is considered as A and the nearby to root node is considered as B. Root node is considered as A and nearby to root node is considered as B node. So whatever the balancing factor on this B node, according to that we need to do the rotation. Again see, after deletion whatever is the root node is considered as A and nearby to root node is considered as B node, and whatever the balancing factor on this node, that is considered as a deletion. So because here on B node what is the balancing factor? It is -1. So which rotation we will do? We will do R-1 rotation to balance the tree. As we are able to see the balancing factor of this tree on this node is +2, so we need to rotate it. Now we will do the rotation. Now the one thing we need to remember, as we are doing R-1 rotation, till now we have learned R0 and R1 rotation, in which rotation was simple, only right hand side. But this is R-1 rotation, it is little tricky, so we need to see this. It can be happen in two parts, it can be happen in two steps, we can say. So first we will see the sub part of the tree, from where we will consider the balancing factor from B node. From that part only we will consider the tree, and we will take only that part for the rotation in step 1. We will take two steps in R-1 rotation. Step 1, in step 1 what we will consider? We will consider only sub part of the tree from where the B node gets started, only that part. The A part or we can say the A node of the tree we will not touch. We will touch only the B node and that part only. So we will do rotation for that part only. So how we will do rotation? We will do rotation in R-1 from the nearby to this B node 28. So what we will do? We will rotate it on left hand side. We will rotate from this node from left hand side. Only sub part rotation will happen, and we will rotate from this node. This node will go up and 22 will go down. We are rotating from this node left hand side, so we will see, and this part will remain same. We will not do any changes in this part, and this is step 1 only, so we will not. Let's see here. First 44 and 48 will remain same. We are not going to do anything on this part, but from B node, from the sub tree, we will rotate it on the left hand side. So 28 will go up, 28 will go up. So we are writing like this: 28 will go up. After that what will come? 22 will come down, 18 will come down, and 28. After that what is there? 29 is there, and here 23 is there. 23 is there, so we can't write 23 here. So we are able to see, as it is based on the property of binary search tree, so we are able to see that it can come on the right hand side of the 22. 28 directly is coming on after that, after rotating, because after that it is there. So 23 is also there, so we can add 23 here. After 22 we can add 23 based on the binary search tree property, right? So till now we have not touched this part is same, but we have touched this part, sub part, as we have as I have shown dotted line. So this is left rotation we are doing. So 28 will go up, 22 and 18 are coming down, 29 after 28, and 23 is there, and according to the binary search tree property 23 can come after, or we can say on the right hand side of the 22. Now this is step 1. Now in step 2 what we are doing, now we will rotate the entire tree, because this is the middle step, so we are not seeing the balancing factor here. After this step we will see the balancing factor. Now what we are doing, because rotation is R-1 and R rotation, so it will rotate the entire tree on right hand side. So when we are rotating the entire tree because of the R-1 rotation, so we are rotating the tree on right hand side, so 28 will go up. We are rotating the tree on right hand side because R-1 rotation. This is step 2 or final step we can say. So 28 will go up and 44 will go down, 48 will go down, then 22 will come here, 18 will come here, and 23 will come here, like this. 28 will go up, we are doing rotation R-1, so right hand side we are rotating right hand side, so 28 will go up, so 44 and 48 will come down, and after that 22 and 18 are there, and on the right hand side of 22 23 is there, so we will write 23 here. Now the rotation is completed. The step 2 R-1 rotation is done. So now we will cross check the balancing factor of this tree. So 48 there is a I think one more node is left, right? Correct. 29 is left. So 29 now we are able to see, because 28 is the root now, so 29 cannot come on left hand side, it can come on right hand side only, because 29 is greater than 28 and 28 is the root. Again following the property of the binary search tree, so it will come on the left hand side of the 44. So 29 will come over here. Now the balance rotation is completed. Now we will see the balancing factor. 48 there is no child, so 0. 29 there is no child, so 0. 44 one child on left hand side, one child on right hand side, so plus 1 minus 1 0. 23 there is no child, so balancing factor is 0. 18 there is no child, so balancing factor is 0. 22 one child on left hand side, one child on right hand side, so plus 1 minus 1, balancing factor is 0. 28 2 level on left hand side, 2 level on right hand side, so plus 2 minus 2 0. So its balancing factor is 0. So now we are able to see the balancing factor is 0 here only, and according to the AVL search tree 0 balancing factor is correct. So this tree is balanced. So we are able to see that if we are deleting any node on right hand side, and after deletion if we are getting the balancing factor at B node -1, so we will go with the R-1 rotation. R-1 rotation, it will consider 2 steps. First only the sub part will rotate on left hand side, and after rotation the sub part on left hand side we will rotate the complete tree on the right hand side, and after that we will cross check the balancing factor. If tree is balanced, so we can say the deletion is done perfectly in AVL tree.